this lesson is about subtracting fractions, and we're going to introduce it with a model again. So when we subtract fractions, the strip diagram model is going to look a little different. I'll show you what I mean. So you're always going to have your one whole at the top as your reference point. I'm not adding or subtracting the one whole at any point with any of these problems. So I'm going to have that drawn on there for my reference point. And then if I'm doing something like 7/8 minus 1/4, your model will show your eighths. A couple of them are not the same size. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, and 7/8. So to show subtraction with the models, what they normally do is put another bar here to show what 1/4 is. So I can see that 1/4 is equivalent to 2/8 because it lines up perfectly. These models only work when your denominators jive together. So you'll get quickly to a point where you're not going to be able to do these because the numbers will get so big. And then for the subtraction, they usually have like a dotted line here where it's like set apart, and they'll put a question mark here. So you're looking for this section here for your answer, the missing piece. So when I have the models here, I don't really need to work it out because I can just count 1, 2, 3, 4, 5/8. So 7/8 minus 1/4, if I take off this, I'm left with 5/8. So when you're given a model, it's a really easy way to find your answer without having to work it out. But again, the models only work for so long, and then you're just going to have to work out the problem like we did yesterday with subtraction. So when we're subtracting fractions, I'm going to do it the same way as I did yesterday. The book will give you a problem like 1/2 minus 1/3, and they always stack it up this way. The kids that I see try to write on top of the numbers and not rewrite their problem always end up adding and subtracting the wrong numbers. It happens every year. So I'm asking you, if you would, to take 2 seconds and rewrite your problem like this. If you stack them on top of each other, you're going to be so much more successful. Now we're going to look for the LCD again of 2 and 3. So while you're getting started, you're probably going to want to write out the LCD every time you do it, and then you're going to get to where you don't need this anymore. So if I look at multiples of 2, 2, 4, 6, I'm going to stop because I know I'm going to have 3 and then 6. Most of the time you're going to find the least common denominator really fast, just because you know that 3 times 2 is 6, and that one's going to work. So the first thing I'm going to do is convert both of these fractions over to sixths. I know 2 times 3 is 6, so now I'm going to do 1 times 3, which is 3. 3 times 2 is 6. 1 times 2 is 2. And now I'm just going to subtract 3 minus 2, which is 1/6, and I'm done. I'm going to show you one more here. So if I wanted to do 9/10 minus 2/5, I'm going to set it up this way, 9/10, 2/5, and look for the LCD of 5 and 10. Most of you guys are already saying 10 in your head. 5 times 1 is 5, 5 times 2 is 10, 10 times 1 is 10, so I'm done. So 9/10 is fine. I don't have to do equals 9/10 or multiply it by 1. I'm just going to leave it alone. But this guy, I've got to change him into tenths and dress him up. 5 times 2 is 10, 2 times 2 is 4. Now I can subtract. 9 minus 4 is 5. The denominator dominates. He always stays the same. But I'm not done. 5 tenths can be simplified. You're always going to have to ask yourself, can I reduce it? Can I simplify it? Well, I know 5 is half of 10, so this is equivalent to 1/2. And now I'm done. If you answer 5 tenths on your problems, they are not going to be counted correctly. You always have to reduce to lowest terms.